Welcome to exercise 1A, the beginning of your PreMethods journey. This is how we will be running this class. So this exercise is a consolidating exercise. So I hope that you have a firm understanding of most of these concepts already, but you still need the chance to refresh as we begin this new topic. So these topics that we'll be covering, or the learning intentions, are collecting like terms, multiplying and dividing expressions, expanding the brackets, factorising simple algebraic expressions, and evaluating expressions. Each one of these relate to an exercise, as you can see here. The first one goes to exercise 1, and each one of those relate to a question. So your pre-learning, what you need to do before our class, is these questions 6, 7, 8, 9, 10, and 11. So let me just get the textbook. And you can, well, if you get a chance to look at it yourself, the questions in the exercise are quite long. Like, for example, question 6 has A, B, C, D, all the way through to R. I don't know how many numbers that is. You don't need to do all of those, a third or a quarter. As long as you're doing some of the more difficult ones in those questions, then I am happy. So I'll assess how you've gone on each of those questions and if you've done a suitable amount. But yeah, that's up to you, and you need to be confident that you can do the hardest questions in that question. Okay. So the key ideas, as I said, we hope these are revision, but I've gone ahead and written a number of things here to be clear, and help me read it out to you now. So a term, when we're talking about algebra, so 5x is a term, 7x squared y is a term here. Okay, so and even 7 is a constant term. These will make more sense as we get onto like terms, of course. The number that multiplies them is the coefficient. Okay, so if I go back to that 7x squared y, so the x squared y is the term, and the coefficient for that one is 7. If I look at the constant term here as well, let me zoom up a bit. 7 here, its term is that there is no x, there is no y multiplying it, so it's like a constant term. So it's like a coefficient and a term in one. So an expression is a bit of algebra or numbers put together. They could be added, multiplied, divided, but it's one set of things. And the easiest way to think about that would be in relation to the equation. So an equation is basically two expressions that are equal to each other. That's what the equal sign means. And you could even say sometimes a division is two expressions, one dividing another. Okay, but the whole thing together is the expression. We can evaluate our expressions based on pronumerals. So the pronumeral is the variable in there, and obviously that has the word vary in it, because sometimes when we have an expression we're allowing it to vary, but sometimes it's just a placeholder. So when we figure out what the variable is, then we know exactly what the rest of the expression is. We can substitute it in, and it's really important when you substitute to quite often put those brackets there, as you can see around the squared, for the simple reason that sometimes you're multiplying a negative by a negative, or you're squaring a negative, etc. But I always like to put a bracket there and think that the value for x, so you can see in this one, that x we're told that x is equal to -2. And so instead of having the x there, now I've got brackets and the numbers go in there. And then you go ahead with your mathematics just like you normally would. As you can see here, like terms does help explain terms a bit better. It's worth pointing out that x squared and x are different terms. Okay, so even though well, it's obvious that things that have different pronumerals are different terms, but it's also really important that everything is to the same power, or divided or multiplied or whatever. Once we got to this stage of maths, we don't use the terms the symbols for multiplication and division, unless we're actually going to do something with them. But normally we'd represent division with a fraction, because that's exactly what a fraction is. And if we're talking about a number times a pronumeral, we just write the number next to it, and that means multiply, not add or anything like that. But quite often you'll still use multiplication when we're talking about two numbers. Okay, so the distributive law, that is just a formal or fancy way of saying expanding brackets. And factorising is like expanding but backwards. Okay, so that's what I've written there. You should always check, okay, after you've factorised, if I expand these brackets, does it go back to the original statement? Some of these other ones, names you don't necessarily have to remember, but I've given an example here. So associative is just saying the order, well, it doesn't matter if you do it to this, well, A times B times C is the same as A times B times C here, right? And this works with addition as well. So one way to think about this is the numbers that I've given you here. So 3 times 12 is equal to 9 times 4. They're both 36, right? And the reason why this works is because multiplication is associative. So because I can break up 3 and I can break up 12 into 3 and 4, and I can break up 9 into 3 and 3. So 3 times 4 is equal to 3 times 3 times 4. Okay, that's why that works. And commutative means it's a better way of saying the order doesn't matter. Okay, so that, I was a bit confused with that with the associative and how I was going to express that. But so A times B is equal to B times A, right? You know that, and A plus B is equal to B plus A. But there are times or types of operations like division and subtraction where they are not commutative. But if you can break up fractions, instead of thinking of A on B as A on B, if you thought it was A multiplied by 1 on B, then it works. And the same goes with subtraction. If you thought of A plus minus B is equal to A minus B, then minus B plus A is the same. But generally speaking, you've got to be very careful. Okay, then the order does matter with subtraction and division. So, yeah. The last thing is identity and inverse. These are very much linked ideas, and these can get quite complex if you really think about them deeply. But they're in a simple matter, these are things that you use all the time. Okay, so you know that 1 times anything is itself, or anything plus 0 is still itself. And you're constantly, when you're doing your algebra or trying to solve any sorts of equations, you're constantly looking for this identity and inverse. So you do what you can to get an inverse. So for example, if you're trying to get rid of a multiplication, you'll go by the multiplicative inverse, which is 1 divided by that number. And that undoes the multiplication and brings back 1. And if you're doing addition, you don't want this thing added to it, then you add its negative. Okay, so the inverse is what brings it back to its identity. Okay, so you should be able to see the additive identity is the negative number. Okay, because it makes this thing, this expression equal to the additive identity 0. And the multiplicative identity is 1 divided by that number. Okay, so A times 1 on A equals 1. And remembering to do the same thing to both sides, you can see exactly what I'm talking about here. Okay, so if I was trying to figure out what x is, and we're going to do some solving of equations in this unit, then I'm going to start off with 2 plus 2. I'm trying to get rid of it, so I think of its additive identity. Inverse. Okay, so negative 2 is the inverse of positive 2. So I take away 2 from both sides, and now I've got 3x equals minus 1. And I'm multiplying this x by 3, so 1 divided by 3 is the multiplicative inverse of 3. I do that to both sides, So if 3x plus 2 is equal to 1, because I've used all these inverses to get the identity, I now know that x is equal to minus 1/3. We're taking a bit of time here, so I'm going to try and speed up. This mystery problem will be on the board for our first class, and I'm going to get you guys to have a go at it. Now, when we do that, when you look through this OneNote, the videos are here. So this, if you were to click on this video will start playing. Okay, so this is the textbook's version of that example. Okay, so my discussion video, obviously at the top of the page. Hopefully you've clicked on that. So here's an example of collecting by like terms. I've already had a go at it. You can watch their example, read what I've done here. It should be pretty straightforward for you. So the a squared and b are like terms. So this a squared times b could be another x itself. And you would know that if I had have said, for example, 3x minus 2x, that equals x, right? So if I considered a squared times b equals x, that's the case there. And here we've got the two different terms, okay? So we've got x and y, and x and y squared, and y squared and x. Now x and y squared, so y squared x is equal to x times y squared because of that rule, commutative, okay? So multiplication is commutative. And the other thing you have to do is multiplying and dividing expressions. Okay, so you can use things like associative and commutative, as I've done here. I'm guessing you don't need to remember the names of them, so to speak, but because they're slowly becoming very natural to you as you use this more and more often. What else are we doing in this one? Okay, so this is just asking you to simplify it. So in the end, I've put the numbers together. So this is all about associativity or cancelling out common factors. This one I showed, it's sometimes simpler to, I mean, you should know by now that 7 divides into 14, but the reason why is because 14 is equal to 2 times 7. So if I wrote it out as that, I just cancel out those factors, okay? Expanding brackets, that should be fairly straightforward. That's distributive law, okay? So 2 times x plus 4 is equal to 2 times x plus 2 times 4, or 8. And I just put a little side note for this one. That's because you know that 3 times 12, I think we used that before, didn't we, is equal to 36. But another way of saying 12 is 3 times 10 plus 2. I know that's how I do multiplying numbers bigger than 10 in my head. So that's equal to 3 times 10 plus 3 times 2 equals 30 plus 6 equals 36. Okay, so this rule, don't let any algebra things confuse you. You would do normal arithmetic in your head like that anyhow. Factorising, so I've looked at what number divides into both these numbers, or what algebra pronumeral divides into both of these ones, okay? And remembering that x squared is x times x, so 3 divides into 3x and 9, so I've put that at the front. Once again, you can check by expanding. For this one, 2 and x divides into both of these ones. So this is x times 2x plus 2 times 2x. And so I've taken that factor out the front and undone the distribution, so to speak. Okay. Once again, check that works. Okay. So for example, my check here would be, so 2x times x plus 2 equals 2x times x is 2x squared. 2x plus 2x times 2 is 4x. So it works. Okay, so if you're in a test scenario and you're feeling under pressure, you've done some factorising, go back and check that way. And this one is evaluating expressions, and you can see that I have put in the brackets here, okay? Because so a squared, if we've been told that a is equal to -3, well, I've put the brackets in, I've had to square all of the value of a, okay, which is a negative at this point. And and I did the same for the 5 and the -1 in regards to b and c, and as a result I was able to get the right answers. All right, so that is everything in this class. I don't think there's anything that'll be too challenging for you guys. You've chosen PreMethods, so clearly you're mathematical guns. So I don't know what I've done there. But there is quite a bit to do. So it's just more about checking off your skills, and hopefully you get this off to a great start and you do really well on your first mini assessment. All right, good luck, guys.